Hey, good afternoon. By now you should have seen the Unit 9 Notes to Study, Conservation of Energy. I thought I'd go over it with you anyway, just in case. You do have a test next week, Wednesday, Thursday, but I'm going to go through that with you too. Prior to you taking it, you're going to have some practice things to work on Monday and Tuesday, and then you'll test Wednesday, Thursday. All right, so what is energy? Energy is the ability to cause change, the ability to do work. It is what makes matter move or change. Energy is measured in units called joules. Another rich old white dude, right? All right, two major types of energy. We have potential energy. It's the energy of position. It is a stored energy most of the time. The one that we talk the most about is gravitational potential energy. So being up above on a ladder or on a roller coaster, a stretched rubber band has stored energy in it. So that's the main thing. Now, the way we express it, gravitational potential energy, definition again, energy an object has because of its position or condition is another way it's described. This type of energy is abbreviated as PE or E of G, okay, meaning energy due to gravity, right here, okay. Chemical potential energy is energy that's stored in bonds between atoms, such as chemical energy in a sugar molecule. When you take biology next year, you'll learn more about that, but we did talk a bit about that this year. Nuclear potential energy is energy that's stored in the nucleus of an atom. We spent a lot of time talking about that first semester. And then lastly, you have elastic or spring potential energy. We don't spend a lot of time on that in physical science, but you will whenever if you take chemistry integrated, you'll talk about rubber bands, compressed springs, bungee cords, etc. The other major type of energy we want to talk about is kinetic energy. Energy due to an object's motion. Kinetic energy depends on the amount of mass and the speed of the object. So you increase the mass, you increase the kinetic energy. You increase the velocity, you increase the kinetic energy. Examples or forms of kinetic energy: movement or motion of objects, substances from one place to another. We abbreviate it as KE, but you're going to see it as E of K. Okay. These mean the same thing, but this E of K means that is how you're going to see it should you take integrated chemistry. Thermal energy is heat energy, the internal energy of a substance due to the vibrational movement of atoms and molecules making up the substance. We're going to be talking about thermodynamics for our next unit, so be ready for that. Electrical energy, we all know what that is. We like electricity. That's the movement of electrons in one direction. And then we have radiant energy, which is also known as light energy. It moves in a transverse wave, meaning it goes like this. Radio waves, infrared, visible light, ultraviolet, and X-rays are all forms of radiant energy. Modeling energy transformations using energy charts and energy bar graphs. It's just a way to model energy changes and transformations without giving numbers. It's a bar graph, basically, where it basically represents a percentage of the amount of that type of energy without saying directly, oh, this is 50% kinetic, this is 50% potential. Altogether now, it's 100%. Okay, that's basically what we're saying. Energy graphs are designed to show what type of energy is present at different stages during a process or a change. We love to use the example of a roller coaster. Okay. Most often we will look at the stages before, those are called initial, and after, those are called final, an event occurs. But sometimes on quizzes, for example, we look at diagrams for the intermediate. So what's happening in between after the roller coaster's already started, or after the guy on the skateboard has already started rolling down the hill. Okay. All right. If we have an egg at rest at the top of a two-story building, it is initially at rest, meaning it has 100% gravitational potential energy. No kinetic, because they told us it was at rest. Okay. If the egg is dropped off the building, then the gravitational potential energy amount decreases as kinetic energy, the energy of motion, begins to increase. So decrease in potential, increase in kinetic. Okay. Right before it hits the ground, it has 0% gravitational potential energy, okay, because it has all converted to kinetic energy, 100%. The energy of position was transformed into energy of motion. This transformation is often illustrated using graphs, okay? And we like to use energy graphs. You'll see that this one right here shows you some numbers. You can use numbers or not use numbers. In this case, we have numbers. There's a video on here for making energy graphs. I'm hoping you have actually watched that. If not, you do have access to this and you can watch it as many times as you need to.